Okay, so here we are back at variance and inferential statistics. In very general terms, the whole goal of this course, the goal of inferential statistics, is to detect meaningful and significant patterns in research results. Variability plays an important role in the inferential process because the variability in the data influences how easy it is to see patterns. In general, low variability means that existing patterns can be seen clearly, whereas high variability tends to obscure any patterns that might exist. Maybe you've heard the term the signal and the noise. When there's high variability, we have too much noise and we can't see the signal, the pattern within our data. That's what this is referring to. So we're in the last section of chapter 3. We're going to talk about z-scores, percentile values, and quartile values, and then we're going to construct a box plot in SPSS. So z-scores, or standard scores, are used to identify and describe the exact location of each score in a distribution, namely how many standard deviations a raw score is from its population mean. So for example, suppose you receive a score of 76 on a statistics exam. How did you do? Your score of x equals 76 could be one of the best scores, or it might be one of the lowest scores. To find the location of your score, you must have information about the other scores in the distribution. So we have here a sample and a population. We're interested in the sample. So the z-score is equal to your actual score minus the mean for the class divided by the standard deviation. So here we see two distributions for exam scores. In the first one, in graph A, the standard deviation is 3, meaning most scores were within 3 points of the average for the class. Therefore, within 3 z-scores of this average for the class, therefore the z-score of x equals 76 is 2, which is 2 standard deviations above the mean, i.e. a very good score. In the second graph, the z-score is 0.5, and therefore that score was within 1 standard deviation from the mean. Still better than the average, but not as good as in graph A. Z-scores specify the precise location of each x value within a distribution. The sign of the z-score, positive or negative, signifies whether the score is above the mean, positive, or below the mean, negative. The numerical value of the z-score specifies the distance from the mean by counting the number of standard deviations between x and m, no units of measurement like feet or pounds, just standard score. When a z-score is greater than +2 or less than -2, it's considered significant. So a standard normal z-score distribution, the mean is equal to 0 with a standard deviation of 1. And when a z-score is positive, it's to the right of the mean, which is 0, and if it's negative, it's to the left of the mean. Percentiles are a type of quantile or fractile in which partition data into groups with roughly the same number of values in each group. Percentiles specifically partition a set of data into 100 with about 1% in each group. The 50th percentile is the same at the median, with half of the values below it and half above it. That's all you need to know about percentiles for this class. Quartiles, measures of location noted Q1, Q2, and Q3, which divide a set of data into 4 groups with about 25% of the values in each group. We're going to show these using box plots, or also called box-and-whisker plots. They show the center and the spread of data. They identify skewness and outliers. They're easy to compare of different variables, and they're equivalent to the 5-number summary: minimum, first quartile, second quartile, which is the same as the median, third quartile, and maximum. So in SPSS, we're going to create a box plot. You have to have one variable as continuous and one as categorical. So for example, here we're looking at COAT9 levels in smokers by sex. We go to Graphs, Chart Builder. We scroll down to where it says box plot, click it, we'll get this picture. You're going to drag the box plot in the main viewer pane into the main viewer pane and put the continuous variable on the y-axis and the categorical variable on the x-axis, and then click OK. And this is what we get. So the females have higher levels of COAT9 in their bodies in smokers by by gender. So females have higher levels, whereas males have a higher variability, as you can see between the bottom whisker and the top whisker. So we have, in the box plot, you have the median is the line, you have the minimum is the bottom line, the first quartile is the bottom edge of the box, the third quartile is the top edge of the box, and then the maximum is the upper whisker, with the red part is the interquartile range. Alright, when we get to SPSS output, this is with 2 outliers. I changed some of the data and reran the box plots, and when you have values that are 1.5 to 3 times the range of the values within the box plot, they'll show up as outliers, which I've circled here in red. To wrap up, so we've talked about measures of center, variability, z-scores, and box plots. We're going to be moving into looking more at z-scores and standard scores and normal distributions, and then we're going to move into hypothesis testing.